Okay. All right, so everybody have a calculator out that you can at least help me calculate. Let's go quick. Participate, because we go 10 times quicker if I'm not waiting for the answers, you know, like waiting 10 minutes for you to answer me. Participate. It's boring if you don't. Okay, so what officially makes an equation linear versus quadratic versus cubic versus quartic? How do we know it's linear? There's not a necessarily incorrect answer. Just try it. If you're wrong, it's okay. It doesn't matter. Okay, I like his answer. You know this goes in a straight line because you know what a line looks like. That's true. So this is, how else? That's true. That's one way. Anyone else give me another way we know for sure?
Like whether it's x or x squared or x.
Yes, right on. That's exactly what I'm looking for. He's saying that this is x to the first power, correct? Making it linear. Like he said, if it's x2, that's x squared. Does everybody see? So we know it's linear because it's degree 1. More commonly seen written like this, mx plus b, where this is the slope, this is the y-intercept. We're not graphing though, we're solving. So, now what makes something an equation versus an expression? You do need to understand vocabulary because otherwise it can get confusing. So what makes this an equation is there's an equal sign. An expression would just be mx plus b. It's just an expression. We didn't set it equal to something and we can't solve it. It's not an equation. Okay, so literally, basically, here's the lesson. And then we'll practice, pretty much. Okay, so when solving a linear equation, or really any equation, you isolate the variable piece by piece using correct algebra in the correct order. And we undo things with inverses. And then, once you have the variable all by itself, you're done. You can check your answer. Easy stuff. Okay, so just kind of fun fact for you. You don't need to necessarily write this down because it is actually you already know all this stuff. It's just I'm making a point here. When you're simplifying something, an expression, not solving, not an equal sign, just simplifying, you simplify in this order. Please excuse my dear Aunt Sally. We've all heard that saying. So you take care of parentheses, then exponents, multiplication and division, addition and subtraction. Now when we change it and put in an equal sign, instead of simplifying, we're solving it, you actually do that just backwards. So it's sad met. So you would take care of subtraction and addition, division and multiplication, exponents and parentheses last. Now think about it, guys. What does addition, subtraction? What does multiplication, division, and so on and so on. Everybody good? So these first few examples are going to be so easy, you shouldn't be writing it down because it's so easy that it's just you're going to get more out of it by watching. Hey, look at this example. If I said solve for z, you would say, okay, I got to get z alone piece by piece. What would we do first? Minus 3. So we would have 4z equals -1. Then what? Yep, 1 does multiplication, division, so we divide by 4. Therefore, z equals -1/4. Everybody good?
Yes.
Now, it's just a hoop we have to jump through. They won't let us write it like this. They want us to write it this weird, fancy way. So just do it, okay? If we're solving, we're going to get an answer. Yes, that is our answer, but this is how we write it. So they do this thing. They write answers in sets. So here's my answer. So you'll write a little set. And you're saying, okay, we were solving for variable z. That's where you start. We were solving for variable z, and we got the answer for variable z such that this like bar, this straight up line just means such that. So we have a variable z such that z equals -1/4. That's our answer. It's just a way of writing it. It's a hoop we just have to jump through. Okay, and you have to write it like that, or I have to dot some points. You have to write it with the correct notation. So, once again, I'm going to read it again. This literally just says, we have a set, which means here's my answer set, for variable z, such that z equals -1/4. Now, what we should understand is that if we were to plug in -1/4 up here, it's going to make it a true statement. So yes, on our homework, there is the answers available to you to check your work, but on a test you wouldn't have that. So once again, practice checking it by hand. So watch me check it. So I would plug in. We know that this is what will make this a true statement. So we would have 4. Instead of a z, we have z is -1/4 plus 3 equals 2. So let's see if this is a true statement. Isn't 4 times -1/4 4 divided by -4? Same thing, right? So -1 plus 3 equals 2. Isn't that 2 equals 2?
Yeah.
We know we've done it right. Sweet. Okay, moving on to the next example here. Some of these are coming off your homework, but they're not assigned homework problems. So I would just write down, if you need to take a note, write down 21 so that you know which one to refer back to. If you're like, oh, we did an example like that. Which one was it, you know? Okay, so 21, this is 21 on the green sheet. Once again, it's really fine that you don't have it. Here, like, some of you might not even need to take notes on this. You can just watch. Okay, if I said to you solve for W, You would say, okay, now look at this side of the equation. There are multiple w's. You're not moving from one side of the equation to the other. You're on the same side. So we're not going to change the signs here. We're literally combining like terms. Does everybody see the difference? Negative 3w's plus 2w's is how many w's? Negative 1w. So we cross them out, then we have still plus 5, don't we? Equals negative 4. So then what? Minus 5 minus 5. So we have negative w equals negative 9. Correct? Divide by? Good. Divide by negative 1. So then we have w equals 9. So we would say we have the set for w such that w equals 9.
I know.
Easy, right?
That's the hardest part of the whole question.
I know. The hardest part is finding the answer, right? Hoop jump.
They look weird.
Okay, next one. So look at this one. We have two z's, but they're on opposite sides of the equation. We need to use addition or subtraction. Don't just start floating things together. So do you want to bring this over or this over? It doesn't matter.
5z,
No.
3z.
Okay, add 5z. Add 5z. So then that's gone. 3 equals, what's negative 3z plus 5z?
2z plus
2z is plus 1. Do you guys see how really, for the most part, it would be pointless? This is kind of to take notes, because it's probably easier to just watch because I'm going so dang fast.
Oh, yeah.
Okay, now what?
minus 1.
Minus 1. 2 equals 2z, so z equals
0.
1. Yeah, good.
0.
No, that's good.
Numbers?
So we have the set for z such that z equals 1. Everybody good?
Yes.
Easy peasy pudding pie, right? Okay. All right, so let's solve 28 two different ways. So this is 28. Way number 1, there's not an incorrect answer here. Give me a way to solve this one. What would you do first? Oh, I like that way. You're saying that this is 4 times all that stuff, and there's nothing added right here, so it's all by itself, so we could divide both sides by 4? True. So now we would have z minus 2 equals 3. So z equals
5.
5. I'm going to just write it like this for a second, because is everybody good? You get the picture. You won't write it like that on your homework. Okay, what's way number 2? Distribute, correct? So you have 4 times all that stuff. I would make sure I distribute it. 4z minus 8 equals 12. You'd add 8 over. So you'd have 4z equals 20. So z, divide by 4, so z equals 5. Either way is correct. Everybody good? I don't care how you do it. It's just I just want you to see things. Okay, I do not want you taking notes here. This is a big long one. I just want you to watch. You're going to get more out of it. So it says solve for w. This is a big nasty one, but it's really not that bad if you just look at it in sections. So you look and say, well, there's a lot of parentheses, so what's going on with those? Don't we have 8 times all that stuff? Distribute, distribute. So we would have 8w plus 16. I cross things out as I go so I don't miss anything. Then we still have minus 3w, don't we? Equals 7 times all that stuff. Distribute 7. So we'd have 7w plus 14. Is everybody good?
Yes.
Now I have positive 2. Now if that was minus 2, we would distribute the negative in right here, right now, and so then it would be taken care of. But it's positive. 2 times 1 is
2.
positive 2. 2 times negative w, negative 2w. Now everybody, next step would be to combine like terms on this side, and we wouldn't change the sign here. 8w's minus 3w's. 5w's plus 16 equals, combine like terms, 7w's minus 2w's. 5w's
16.
plus 16. Okay, now don't get thrown off here. Your steps are always the same. Don't we now need to put our w's together? That's usually what our step is. So let's go ahead and subtract 5w from both sides. So that cancels out, and that cancels out. Uh-oh. 16 equals 16. Isn't that what we're looking at? W disappeared. Well, is that a true statement? Does 16 equal 16? That's not our solution. That's a true statement. We didn't solve for W if there's not a W, but that is a true statement. So if that happens, it's because, let me direct your attention right back up here. Look at this and this. Aren't those the same thing? So think about it. If I plug in a 0, won't the answer be the same? Plug in 1, the answer is the same. Plug in 2, so any number works, correct? They're the same. So our answer is all real numbers. So you'd say the set, no matter what we plug in, the set for W such that W is all real numbers. Or you could write out in words all real numbers. Does everybody see? So basically here's the rule, the trick. If you're solving and your W's or your variable disappears, if it's a true statement, the answer is all real numbers. Now let's say that the W disappears and you get something like this. Let's say that the W disappeared, and let's say we have this. 5W plus 2 equals 5W minus 3. So we'd subtract 5W. So now don't we get 2 equals negative 3? Is that true? 2 doesn't equal negative 3. Therefore, there is no solution. You guys see the difference? Okay, awesome. Cool. Okay, I do need you to write this one down. If you were in my class last year, this one will probably seem decently easy. If not, this is a good reminder. Okay, so right here, notice we are now dealing with fractions. We're adding fractions. Now here's a rule. When adding or subtracting fractions, you have to have a common denominator. And then because we're solving, once we have a common denominator, we can ignore the denominator and solve using the numerator. So, what I want you to notice is, this is a fraction. Boom. This is a fraction. This is not written as a fraction. If you have one fraction, you want to write them all as fractions. So what you're going to do is technically say, well, this is a fraction. It's divided by 1. That is a fraction. You're going to write them all as fractions so you don't forget to do this next step. We need the denominators to be the same. If they're the same, it doesn't matter what same they are. They just need to be the same somehow. So what's something that we can make all the denominators equal to? 12. Couldn't we make them all 12? Let's do that. So how would you make 4 a 12? Times by 3. Well, if you do that to the bottom, you've got to do it to the top. Now I want to point something out. You've heard me say, if you've been in my class before, we're not changing the problem. Here's why. Isn't 3 divided by 3 1? Isn't anything times 1 still the same thing? So we're just taking and writing it in a different format. It's still equal because we're timesing by a 1. Now look right here. Well, we need to make this 12. What should we multiply by? 2. If you got to do that to the bottom, you got to do it to the top. And we need this one. See, if you don't write the 1, people forget to do this one. What's the denominator need to be? So you multiply by 12 over 12. Okay, good. Okay, let's rewrite what we have here. Now here is where people mess up. We said multiply the top and the bottom. Well, that doesn't just mean multiply half of the top. It means multiply the entire top. So 3 times that is all in the top. So we need parentheses right here. Don't be that person. Do not be the person. That person that only distributes 3 to the z. You see how that could happen? Okay, here we go. So we have 3z minus 6. 3z minus 6 all over 12. Cool, moving on. We would use parentheses because it's 2 times all that stuff. Next thing to notice. Positive 2. If it was negative, we would distribute the negative and take care of it right here, right now, but it's positive. So we are going to have plus 4z, true? And then we have minus 6, and that's all over 12. And now we have equals. This times this is 84, and then that's all over 12. Now think about when solving, what we're doing is we're finding what we can plug in for z that's going to make this a true statement. So 12, the bottom's 12, the bottom's 12, the bottom's 12. Isn't that already the same? So we can ignore that and just solve using the numerator. So we have 3z minus 6 plus 4z minus 6 equals 84. What you're going to do is combine like terms. 3z's plus 4z's is 7z's. Minus 6, don't be that person that says 0, think. Minus 12, isn't it? And then that's equal to 84. And then what would we do? Add 12, wouldn't we? 7z equals 96, divide by 7. Now you would have to be able to do it by hand. If you had a fancy calculator, like last year, you could still go math enter, and you would know, oh, this is the most simplified fraction. You will not be able to do that. You will have to do it by hand. Does 96 and 7 have anything we can divide out? No, because 7 doesn't divide by anything, right? Besides 1 in itself. Okay, so our answer is, you leave it as a fraction, 96 over 7. I'm being lazy on writing it the fancy way so we can move on. Everybody good? Okay. Okay, I want you to look at this one with me, 44. Don't we need a common denominator? Don't take notes on this one. You just took notes on one just like this. I'm going to fly like a maniac. There's a reason I'm doing it. I regretted not doing it first hour. Okay, what's my common denominator? We could do 12. So what would we multiply by here? 3 and 3. Good. Here? 6 and 6. I better throw in parentheses. Throw in parentheses. Okay, here we go. So we would have 9x. There's a reason I'm doing it. I hope you're watching. 9x plus 3 over 12. Now look, this is where people mess it up. Do not be the person. Isn't this negative 6? If we distribute the negative right here, right now, we're going to have taken care of the negative. So let's just go ahead and distribute it all together. Negative 6 times 7x is negative 42x. Am I right? Yes. Negative 6 times negative 4 is positive 24, and that's all over 12. Now don't be redistributing negatives again. We've already done the distribution of the negative. We're good to go. And then that's equal to negative 5 over 12. Ignore the denominator since it's the same. 9x plus 3 minus 42x plus 24 equals negative 5. And then are you guys good to solve it from there?
Yeah.
Okay, cool. All right.
Why has a question?
Oh,
No, okay, so there's a negative, okay, on that second set, so when we're distributing, you said to distribute the negative along with that 6 into the parentheses, which is the.
yes, because then we'll have taken care of the
Yeah,
negative.
so wouldn't we kind of.
So we took it here, multiplied it in, here, and multiplied it in,
So
so we've already distributed it,
so
so
we're-
straight across.
So how come we don't have a negative 12 on the bottom?
Okay, so remember it's not a negative, you either have to put it with the top or with the bottom. You can't put it with bold, it's not negative divided by negative, because that's positive.
Oh, okay.
Good question.
Okay, I've been writing it a weird way.
Oh, right, yeah, because if we put it with bottom, then we have a negative 12 denominator, that wouldn't make sense.
Yes.
Okay, awesome, good question, I like it. Okay, decimals should not throw you off, guys. This throws people off for some reason. It's no different. You'll have a little mini calculator, grab your calculator, even if it's your phone, and we still just combine like terms the same way. So we need to bring our x's together. So won't we just subtract 0.14x to both sides? And then we have 2.23 equals that minus that. You would do it in your calculator. You do 0.09 minus 0.14, and that's how many x's you'd have, and then you just continue. Do I need to continue? Okay, awesome. Next one. Oh, okay, that is all we needed to learn for 1.1 when solving. Now here's what it's going to ask you. This is something you need in your notes, because it's something you'll want to review before the test, because it's just some wording that you're going to want to study. So it says, okay, now that you know how to find a solution, what type of solution was it? So there are 3 different types of solutions when solving like linear equations. So there's conditional, an identity, and a contradiction. Now it's going to make sense once I explain why each is what each is, but you'll have to probably re-study each before the test. Okay, so an answer that is a conditional answer is when you have one solution. For example, it's saying, does this equal this? Yes, because here's why. So if we get one answer, it's conditional. Here's why. It's saying, when is this a true statement? Well, it's a true statement on the condition that x equals 3, and only on one condition. Does that make sense? So if you get one answer, it's on that condition that it's a true statement, so that's why it's conditional. All right, so then an identity. This is when this happens. So if we're solving, the variable goes away, and we get a true statement, like we saw a second ago, then we know our answer is all real numbers. That means we can plug in anything and it works. That is actually the definition of what's called an identity. No matter what you plug in, it will work. So that's an identity. So it's just kind of something you might want to memorize. So if you get all real numbers is your solution, then it's an identity. Identity is when you can plug in anything and it works. Now if you're going through and you're solving and your variable disappears and you have a not true statement, negative 3 equals 5, it makes sense, it's very intuitive, that is a contradiction, true? So that's the answer would be no solution. Now they write it like this means no solution, or they have an empty set, like literally just a set that's empty because there's no solution. Kind of funny. And so if we get that as our answer, no solution or the empty set, or write no solution, then our answer is it's because it was a contradiction. Everybody good? Okay, so I'm just going to go back to 2, ask you what type, and then I'm going to let you practice them on 1.1 for just a second. So what type of solution is this one? Conditional. This is a true statement on the condition that z equals 96 over 7. All right, looking back at this one, our answer was this. It's an identity. No matter what we plug in, it works. Okay, cool, awesome. I'm going to have you go to 1.1. At the top of the green sheet is the homework problems that are required. Now write this down. You will choose 5 additional problems of your choice besides the top ones, because there's a million problems there. Now, pick the hard ones, guys. Here's what other teachers have done in the past. In fact, I added on extra homework problems because I'm telling you, let me tell you. The other teacher was here. So look at this is still 1.1. This is just 73. yell, so don't talk for a second. Okay, it says state the domain. So domain is x values. If I said to you, what's the domain, I mean, what x values does this function have, or can this function have? So remember, when dealing with fractions, there's only one rule that we have to be really leery of. We cannot divide by 0. The denominator can never be 0. So, let's look at 73.
Teachers, if you will let your students out for a second lunch, you need to go retrieve them. They need to be back in your classroom.
Okay, so this cannot be 0. Is everybody focusing?
Yes.
So let's say this cannot be 0. Isn't that a true statement? Now solve for x. That'll be the value that makes it 0. Does everybody understand? So isn't that the exact same thing we just did? We're just solving. It's the same thing. So you solve the denominator. So what if we get x cannot be negative 1/2, everybody? Subtract 1, divide by 2. Yes?
Yes.
So our domain, we don't have to write it. This isn't solving. I'm just asking you the domain. So when solving, we write our answers in sets. But if I'm just asking you the domain, you can just say all real numbers except x cannot equal negative 1/2. We can plug in anything else. It's all good except for negative 1/2 because that would make it 0. So we just solved the denominator. So what would my restriction be here? All real numbers except x cannot equal. Anyone? Number 74. Negative 8 people. We said it can't equal 0. The bottom.
Oh.
Subtract 8, divide by 5. Do you guys understand? Negative 8 fifths. So how would we do this one? We'd say it can't equal 0. We would solve the denominator only.
Yeah.
You guys understand?
The top doesn't matter at all.
Well, the top can be 0, so no, it doesn't matter. Does that make sense?
Okay.
Okay. Okay, awesome. We're going to do 1.2 now. So, 1.2 is the exact same as 1.1. Here's the difference. Before, in 1.1, they wrote it out for you. They said x plus 2 equals 3. Well, in 1.2, they're going to say it verbally, and you have to write it out what it is. So, it is a little bit more difficult for people just because you have to know what all the words mean. So, here are the key words. Take a picture. I'm going to go quick. If you can't write down, so quick. I'm going to move on very quickly. Sum and more than means addition. Difference and less than means subtraction. Everybody good? Okay. Quotient or fraction will mean division. Quotient or fraction means division. The word product or times means multiplication. We've all seen these words before. So now here's what you have to do. You have to not overthink these, but you have to think advancedly enough. You got to find the right balance. So let's look at some examples here. I'm going to start right here. The difference of 10 and a number x is 6. The difference of 10 and some number x is 6. I start and kind of work backwards. So because of the word is 6, is means equals. I'm going to start there. It equals 6. Taking care of that. Does everybody see? The difference, that means subtraction, of 10 and a number x. What goes first, 10 or x? 10 minus some number x equals 6. And now you solve. What do you subtract 10?
4.
And then divide by negative 1. Does everybody see?
4. Negative 8.
Moving on.
Negative
I'm not going to solve it. That's not the hard part. The hard part is setting it up. Next one. The sum of 2 times y and 3 is 16. Start working backwards. Is 16 equals 16. Done, done, done. The sum, now here let's read this. The sum means, so the sum of 2 times y,
So 2 times y.
2 times y plus 3 equals 16. Now you can solve.
Easy enough.
Everybody good? Now let's read this next one very carefully. I hope you're focusing because this one versus this next one can throw people off. 4 times the sum of a number z and 3 is 15. So let's work backwards like we've been doing. What should I write? Equals 15. 4 times the sum. So you're saying that it's 4 times all that stuff.
Yeah.
Yes. 4 times the sum of some number z and 3 equals 15. Does everybody see the difference in the wording of this one versus the last one?
Yes.
A little tricky, but it just comes with practice. good? Okay. Those come with practice, I promise. Like, you just gotta practice them. Okay, it says the difference of x and 5 equals the quotient of x and 2. So, the difference of x and 5, so wouldn't x go first?
Yeah, so
X minus 5, it equals the quotient, that means division. X goes first, so that's on top, and 2. How would I solve this one? Get a common denominator. So you'd say this is over 1, isn't it?
Yeah.
Times by 2 and 2. Now can't we ignore the denominator? Now we put parentheses. So we have 2x minus 10 equals x. Don't get thrown off here. Combine your x's. Negative 10 equals negative x. X equals 10. Okay, good. Okay, 3 less than a number y is 5 times y. So how would I do this? 3 less than a number y. Which goes first? 3 less than some number y. So you take y and subtract 3, right?
Yeah.
Everybody? 3 less than some number y.
Yeah.
So you'd say, I gotta start with y and then 3 less than that.
Yeah.
It's a little backwards. Y minus 3 is 5 times y. Now I'd say, I don't know why people get thrown off when they see this thing. They're like, what the? That's just a 1y. So we'd subtract 1y, subtract 1y. That's a y. Negative 3 equals 4y. Therefore, y divided by 4, correct?
Yeah.
Negative 3/4. Okay, good. Okay, now I'm going to go to this little to remind you how percents work. So number 9, it says, what is 25% of 40? So this doesn't give us a ton of words. So I want to remind you how percents work. This really helps because there gets trickier ones. This is how percents work. Listen, if you have some number, you times it by the percent, and that will equal some number, okay? So, it says, what is 25% of 40? First of all, 25% has to be written as a decimal. So, to write it as a decimal, a mathematical decimal, we do 0.25. You all know that.
Yes.
Okay, cool. It says, what is 25% of 40? So, doesn't 40 go here? Because it wants to know 25% of that number. And then that equals some number x. We don't know what it equals. Then you type in, okay, 10 equals x. Okay, cool. So now look at 13. This is a little different. Let's set it up though. It says 30 is what percent of 80? I always have people, there's stuff like this on the ACT, and people get a little thrown off. So remember how it's set up. I always go like this. Some number times some percent equals some amount. True? Okay, our percent goes here. We don't know the percent, do we? So let's put x there. Does everybody see?
Yes.
It wants to know 30 is what percent of 80? So 30 is over here, 80 is here. Now how do we solve for x? This is a times sign. Divide by 80. So x is equal to 30 divided by 80, which is some decimal, which is some percent.
Oh, okay. This is like 30 is. Ouch.
37. Yeah, because 30 is.
Yeah. Okay.
Roughly 37%, you said?
Yeah.
Okay,
It's
cool.
actually 37.
Okay, let's look at this one. It says 50 is 90% of what number? 50 is 90% of what? So let's see. It's set up like this. Some number times some percent equals some amount. So 0.90 goes here. 50 is 90% of what number? So where does 50 go? Equals 50. That's in the end. What was the number that we started with? We don't know. So wouldn't we take and divide now by 0.90?
Yep.
Okay, do that real quick. 50 divided by 0.90.
55.
Cool. All good? Yeah? Okay. Now, I'm going to hurry and look and see what time we get out. Makes sense. Okay, everybody, you have to know what these things mean. In fact, this one could definitely be on an ACT. In fact, I've seen some like this on the ACT because it does not require a graphing calculator whatsoever. So everybody, it says the sum of 4 consecutive odd integers is 104. We cannot just shut down when we see like some problem that seems like a little story problem-y. We can't shut down. We just gotta figure it out. So it says the sum of 4 consecutive odd integers is 104. What are the integers? So let's break down what this is even asking us. So first of all, the word integer means whole number. So this says we have 4 consecutive whole numbers being added up that will equal 104. Now here's what you have to know. Consecutive. I'm going to show you what consecutive means. Here's an example of some consecutive numbers. 1, 2, 3, 4, 5, 6, 7. Consecutive just means one directly after another. Okay, everybody? Now it says the sum of 4 consecutive numbers equals 104. We don't know what the number is, plus the next number, plus the next number, plus the next number equals 104. Is that true? The sum of 4 consecutive numbers. Do we know the first number? No. Not a clue. Not a clue. So let's call that first thing we don't know x. We don't know if it's a 1. We have no idea. Let's call that first thing x. Does everybody see? Well, consecutive means, won't this one be 1 more than that? So this is an x plus 1. Won't this one be 2 more than that? So this is x plus 2, true? Everybody? This is x plus 3. This is some x plus 4. This is x plus 5. This is x plus 6. And we could go on forever, couldn't we?
Yeah.
Now here's what the catch. It says they have to be odd. So if it just said the sum of 4 consecutive integers, we would use x, x plus 1, x plus 2, and x plus 3. Does everybody see? But it says they have to be odd. So I'm going to cross out any evens. So the 4 consecutive odds would be x, x plus 2, do you agree? X plus 4, and x plus 6. And now it's just a linear equation. You just have to know what things mean. So what if it would have said even? We would have had to start with x plus 1, correct? And so on. So just draw yourself out a picture like this, and it will help you set up a visualization. So now I need a calculator, all of you. So here we go. Combine x plus x plus x plus x. 4x. 2 plus 4 plus 6. 6 plus 6. So 4 plus 12 equals 104. Solve for x. Subtract 12. And then I'm going to have you divide it by 4. All after that. So x equals what? 23. Does everybody see how we solve? So our first number is 23. What's the next one? What's the next one? It wants to know all the answers. 25, because it's got to be odd. 27 and you can check, is that true? Add them up. They do equal 104. Isn't that so cool? Yeah. Okay, cool. You have to recreate that. Be able to recreate that in any format I give you. I could call it evens. I could say the sum of 3 of those, and so on. Or I could just say the sum of 4 consecutive numbers, period, in a row. So, wasn't that pretty easy now that you see it broken down?
Yes.
Okay, moving on. This is my actually last example here. So we're doing good. Then you're going to have some in-class time to work. I just need to fix, this is number 29. It's actually average of 80. There we go. Okay. Okay, so here we go. It says, now I've actually had students do this. They know that they want an A in my class. They know their test scores. They know the final exam is worth, depending on the grade, depending on the class, it might be worth more than other tests. In my old classes in secondary 3, it was worth the same as all other tests. So they were able to go in and say, I need an A based on my other test scores. What score do I need to get on the final to get an A? So let's look at 29. It says, going into a final exam, which counts as 2 test scores, Kendra has these test scores from a previous test, 84, 78, 64, and 88. What score does Kendra need on the final exam in order to have an average of 80? So everybody, I have to remind you how we find averages. If we have a bunch of numbers, how we find averages is we add up, so like 1, 2, 7, and 8. How we find the average is we add up those numbers and divide by the number of things you added up. So that'd be divided by 4. That's how you find an average. Does everybody remember? Okay, so her first score was 84. Then we have a 78. Then we have a 64. Then an 88. Now we don't know her final exam score, do we? How many of those technically do we have on our grade? 2. Yes. So I'll just write plus x, and then it's an average, so divided by 1, 2, 3, 4, 5, 6 scores, and that's going to need to equal 80. Because then she knows what her test score grades are, or whatever, like what the grade is going to come out. So solve for x. So what would I do first? Okay. Yes? Okay, I like it. So somebody grab your calculator for me. I need some of you to do this. Add up that plus that plus that plus get x alone now? Times by 6. Isn't it gone now? Because we technically went like this. So we have 314 plus 2x equals 80 times 6 is 480. Okay, cool. Now we're almost there. What would we do next? Okay, and then we have 2x equals 166 divided by 2. So she has to get an 83 on her final exam. Does that make sense, everybody? So what if I would have said that the final exam is worth 4 times the test scores? We would have had 4 x's, right? And then at the bottom we would have had 10? 8. 1, 2, 3, 4, 6, 7, 8. Wait. Yeah, you're right. I said 4, right? Okay, whatever. You get the picture. Okay, so that is good to go. I want you now for the rest of the time to practice some on 1.2. So you would start on a new sheet of paper or go back to 1.1. It's up to you.